What if I told you that solving the problem is only half the battle? In high-stakes interviews at companies like Google, a working solution that's inefficient is often a fast track to a no hire. Interviewers aren't just looking for code that works, they want code that scales. By the end of this video, you'll be able to spot performance bottlenecks instantly and apply 5 elite optimization techniques used by senior engineers. Without these, you risk timing out on test cases and leaving the interviewer unimpressed by your algorithmic depth. Let's dive in. Most developers default to nested loops for searching pairs, but that's an O(n)² trap. For an array of 10,000 elements, that's 50 million operations. The two-pointer technique cuts this down to just 10,000. Think about how much faster that is, nearly 5,000 times speed up. Look at this Python implementation. By moving the pointers inward, we decide which elements to ignore without ever checking them. Before I reveal the next technique, can you guess which data structure provides O(1) lookups and is a must-know for every interview? It's the hash map. In Python, we use dictionaries. Hashing is your secret weapon for deduplication and counting. Instead of rescanning an array to find a character, you store it once and look it up instantly. This transforms O(n)² searching into a linear O(n) pass. Notice how we use the counter class here. We iterate twice, but since it's sequential, it remains O(n). This is what Google engineers look for, the ability to recognize when a small amount of extra memory can save massive amounts of processing time. But what about contiguous subarrays? Sliding window optimization is a pattern interrupt for your logic. Instead of recalculating a sum from scratch every time, you simply subtract the element leaving the window and add the one entering it. It's elegant, efficient, and avoids redundant math that kills performance. Check out line 5. That single operation, adding the new and subtracting the old, replaces an entire inner loop. It turns a potential O(n) times k solution into a clean O(n). Pause for a second. How would this behave if the array was empty? Always consider those edge cases. If your data is sorted, a linear scan is a waste of time. Binary search is one of the most dramatic optimizations. It can find a needle in a haystack of a billion items in just 30 comparisons. If you don't mention this to an interviewer, you're leaving performance on the table. Finally, we have dynamic programming. Naive recursion for Fibonacci numbers is O(2 to the n), it's painfully slow. By adding a simple dictionary to store results, or memoization, we ensure every subproblem is solved exactly once. We'll see how to make this even better with tabulation next. We've covered the core pillars, two pointers, hashing, sliding windows, binary search, and DP. Remember the promise: by applying these, you move from a basic coder to a strong hire. These aren't just tricks, they are the fundamental language of efficient software engineering. Top candidates spend 40% of their interview time optimizing, not just typing. Before you write a single line of code, ask yourself, is there redundant work? Is there a faster lookup? Mastery of these patterns is what separates the veterans from the juniors. If you walk into your next interview without practicing these patterns, you're leaving your career to chance. Subscribe to Code Assist Pro to master the implementation details and download our cheat sheet below. Don't let an O(n)² mistake cost you your dream job.